So dear students, so in the previous session, so we started with the memory management. Okay, so we have seen contiguous memory management techniques. So that is fixed partition scheme and also variable partition scheme. So we have seen all that. So the next in the continuation, we will move on to the next one. So that is non-contiguous memory management techniques. Okay, that is the first one is what? Paging. Now understand carefully. So first of all, why we are coming for the paging? So why we are going for paging? The primary reason why we came for paging is okay, to avoid the problem of what? Batao, to avoid the problem of external fragmentation. Bataya last lesson mein, right? To avoid the problem of external fragmentation. Is that clear? Right. So how we are going to implement paging and what is the meaning of paging? We will understand in detail. Okay, everything. Okay, with all the questions and all that. So first of all, just understand the first simple basics. In the paging, we will follow some terminology. We use some terminology. Okay, note down. First copy this. Logical address space. Logical address space. So let's say that is a LAS, or okay, you also call it as a virtual address space. Virtual address space. Okay, VAS. So this is a terminology we will use in the paging. Terminology. Okay. So logical and virtual both are replaceable. So some questions we say logical, some questions you say virtual. Okay. Now understand carefully. Okay. Next, coming to the logical address space or virtual address space. Remember, this is represented. Copy karo ache se. Okay. This is represented in the form of words or bytes. Represented in the form of words or bytes. Okay, इसका मतलब क्या है? If it is a word addressable memory, you represent in the form of words. If it is a byte addressable memory, you represent in the form of what? Bytes. Okay, copy karo, take the running notes. Pause karo video. Okay, so example you can say what? 512 kilo words, or you say okay 512 kilo bytes. Okay, just an example I am saying. Okay, word addressable hai, you represent in the form of words. Okay, byte addressable hai, you represent in the form of what? Bytes. Okay, so that is the meaning of that. So this is a terminology we will use in the paging. Terminology we will use in the paging. Okay, right. Next, now coming to the next one, logical address. Okay, just listen carefully. Logical address, okay, LA, or virtual address. Virtual address. Okay, let's say that is the VA. So you can say logical address or virtual address, same thing here. Logical and virtual both are replaceable. Some questions you say virtual, some questions you say logical. So meaning of both is the same only. Now this is a logical address or virtual address. So this will be represented. Okay, batao, address hai. Okay, address will be represented okay in the form of bits. So if you look at the address will be presented in the form of what? Bits. Okay, so example you say okay 19 bits. Okay, or you say 32 bits. Just an example. Okay, whatever it is, it can be anything. Okay, so address bole to kya bolna chahiye? Okay, bits mein bolna chahiye. So that's it. Okay, so next, logical address or virtual address both are replaceable. Okay, so anything is fine. Copy karo. Pass karke copy karo. Right. So next one is okay, physical address space. Physical address space. Okay, that is a PAS. So we will call it as a PAS, physical address space. Now physical address space hai, so this will be represented in the form of what? Okay, same address space hai. Batao, address space represented in the form of what? Words or bytes. Okay, so note down. Okay, same thing here. So I am writing represented in the form of words or bytes. Represent in the form of words or bytes. Okay, example you can say okay, let's say for example okay 256 mega words, or you say 256 megabytes. Okay, वर्ड्स आर बाइट्स। ओके, वर्ड एड्रेसेबल है, क्वेश्चन में बताया जाएगा वर्ड एड्रेसेबल है, बाइट एड्रेसेबल है, वर्ड एड्रेसेबल है वर्ड्स में बताओगे, बाइट एड्रेसेबल है तो बाइट्स में बताओगे, सिंपल। सो यहाँ पे भी क्या समझोगे, एड्रेस स्पेस, एड्रेस स्पेस बोले तो हमेशा किसमें बताना, वर्ड्स आर बाइट्स। ओके, राइट। एंड द नेक्स्ट वन इज व्हाट, सेम थिंग। ओके, यू नो दैट नेक्स्ट क्या बताओ, फिजिकल एड्रेस, फिजिकल एड्रेस। ओके, पीए। ओके, अंडरस्टैंड हियर, फिजिकल एड्रेस पीए, फिजिकल एड्रेस है। ओके, बताओ फिजिकल एड्रेस, एड्रेस है सेम थिंग, एड्रेस रिप्रेजेंट द फॉर्म ऑफ व्हाट, ओके, बिट्स, represented in the form of bits. Okay, represent the form of bits. Okay, so example you can take, okay, example same thing. Okay, you can take for example 48 bits, just say example. Okay, anything, address बोले तो हमेशा bits से बताना है, right? So this is the, okay, copy करो अच्छे से, copy this carefully. Okay, now understand here. So I am repeating once again. Okay, I am repeating once again. Logical address or virtual address. Okay, both are same. Some questions you say logical, some questions you say virtual. दोनों का मतलब same है. Okay, logical address space है. Address space बोले तो okay, represent the form of words or bytes. Now next, logical address or virtual address, both are same. Okay, some questions you say logical, some questions say virtual. Okay, whenever you say address बोले तो हमेशा you have to say in the form of bits. Okay, you say 32 bits or 19 bits, whatever it is. Okay, so next, physical address space, same thing. When you say address space, represent the form of words or bytes. Address means represent the form of bits. Okay, right. So next is the important point. Just listen here. Next point, the answer suno अच्छे से. If the logical address is given, you can find out logical address. Okay, logical address space is given, you can find out logical address. And if the logical address is given, you can find out logical address space. Okay, so if this is given, you can find out this. If this is given, you can find out this. Okay, now same thing here also. If the physical address is given, you can find out physical address space. Okay, if the physical address is given, you can find out physical address space. Physical address space is given, you can find out physical address. Okay, so if one is given, other one you can find out. Okay, look at here, physical address दिया तो physical address space आएगा. Okay, if the address space is given, you can find out the address. Okay, so how that is, okay, understand carefully. So I am going to write here. Okay, आप लोग copy करो, continuation में लिखो आप. Okay, you write in the continuation. Okay, just listen carefully. So first, okay, so first, let's say first example, just listen carefully. Okay, is it visible? Board is visible there, right? So let us say for example, logical address I am giving. Logical address is, okay, look at here, 35 bits. Okay, tell me logical address. Okay, you need to copy that, copy करना है आपको. Logical address is 35 bits. If the logical address is 35 bits, okay, then obviously logical address space will be how much? Logical address space कितना होता है? Logical address space will become 2 power 35. 2 power 35, okay, words or bytes. If it is a word addressable, you say in the form of words. If it is a byte addressable, you say in the form of bytes. Okay, so let us say I am assuming word addressable, so then 2 power 35 words. Okay, I am assuming word addressable, so 2 power 35 words. Now tell me 2 power 35 words, what is the value of this? 2 power 35 words, what is the value of this? 2 power 5, 2 power 30 words. Yesterday class, okay, 2 power 5 is what? 32. 2 power 30 giga words, 32 giga words. Okay, so this is how, okay, you solve this. Okay, it means logical address अगर आपको दिया गया तो logical address space आप निकाल सकते हो. Is that clear for everyone? So this is how you find out the logical address space. Copy karo, please copy that. So if the logical address is given, you can find out the logical address space. Please copy that. Okay, so next one is if the logical address, okay, is given, logical address space आ गया आपको. Next, now understand here, if the logical address space is given, logical address space, just listen carefully, logical address space is 256 mega words. Logical address space is 256 mega words. Now tell me, if the logical address space is 256 mega words, what will be the logical address? What will the logical address? You write that in the form of what? 2 powers. Right, in the form of 2 powers. So 256 is what? 2 power 8. So mega means 2 power 20. You will not do anything for W. That is just a representation. So 2 power 28. Right. So 2 power 28. अगर आपको bits चाहिए, logical address हमेशा bits में होगा. Then what you have to do? You have to apply log base 2 करना है. So log base 2 means you take only this. So that will be how much here? 28 bits. 28 bits. Okay. इसको log base 2 करेंगे तो क्या आएगा? Log base 2 करेंगे. Log base 2 2 power 28. What is the answer of that? Okay, 28 bits, 28 only, right? So log base 2 करोगे. So I am not writing all this. So easy है, so you can understand. Okay, right. So if the LAS is given, logical address space is given, you can find out the logical address. So this is how, okay, you find out that. Is that clear? Now same thing, okay, if the physical address is given, you can find out the physical address space. Copy किए सब लोग इसको? Copy this carefully. Okay, next. Now I am giving the physical address. Now tell me, physical address is okay 49 bits. Example, physical address is 49 bits. Now tell me, what is the physical address space? बताओ जल्दी. Physical address is 49 bits. Okay, so what is the physical address space? Okay, look at here. So physical address space is 2 power 49. Is that clear? 2 power 49. Okay, words भी हो सकता है या तो bytes में हो सकता है. Byte address से बुलाए तो byte लिखोगे, word address से बुलाए तो word लिखोगे. बस इतना ही, right? So I am assuming, okay, it is a byte addressable now. 2 power 49 bytes. Okay, I am assuming byte addressable. So इसलिए I am writing bytes. Okay, now look at it. 2 power 49 bytes. How much is that? 512 terabytes. Okay, 2 power 9 is 512. 2 power 40 is a tera. Okay, I am not writing completely. Okay, वो भी लिखूं क्या? Easily you can understand. Okay, I write in detail. Okay, so इसको कैसे लिखना है बताओ? 2 power 9, 2 power 40. ऑलरेडी पता है कल का क्लास में 40 के ऊपर है तो 40 को अलग करो, 30 के ऊपर है तो 30 को अलग करो. ओके, 20 के ऊपर है तो 2 power 20 अलग करो. इज दैट क्लियर? 2 power 9 is what? 512. 2 power 40 terabytes. So 512 terabytes. So this is how you find. And the next, now next is what? Same thing. If the physical address space is given, you can find out the physical address. Okay, same thing. Okay, now tell me. Okay, next question 4. If the physical address space is, okay, listen here. So 64 kilobytes. Now tell me, PS is a 64 kilobytes. Then tell me, what is the physical address? Physical address क्या होगा? कॉपी करो, कॉपी करके सॉल्व करो. Please copy that. Okay. Now tell me, so the physical address space is 64 kilobytes. Now tell me, what is the physical address? So 64 is a 2 power 6, kilo is a 2 power 10. So ये b को कुछ नहीं करने का, that is just a representation. If you say log base 2, okay, log base 2 2 power 16. So what is that here? So 16. So PA is what? 16 bits. Is that clear? So that is the, okay, next question. So you need to understand what you understood. अभी क्या समझ में आया? Important point. Okay, if LA is given, you can find out LAS. If LAS is given, you can find out LA. Same thing, PA is given, you can find out PAS. If PAS is given, you can find out PA. So while solving the questions, okay, you need to understand all this. Okay, while solving the questions, you need to understand all this. Okay. Okay. Now, so understand carefully. Next, what is the meaning of paging and what we are going to do in the paging? Let us try to understand all that. Okay, so the answers now say. Now, so next, what is the meaning of paging? Let's try to understand carefully. So this one, okay, was just a representation. So understand the concept carefully. listen to me, okay, what I am going to explain, okay. So please make a proper concentration. Understand here, in order to execute any program, your program will be brought into what? Initially your program will reside in secondary memory, so that will be brought into what? Main memory. So that you know that. So that will be brought into main memory. In order to execute any program, the program will be brought into what? Main memory. Main memory is also called as what? Primary memory, and also called as a physical memory, also called as a RAM, and also called as a physical address space. Okay, it's also called as physical memory. Physical memory means physical address space. Okay, in general you say, okay, physical address space. Understand here, in order to execute the program, okay, I am repeating, in order to execute the program will be brought into what? Okay, main memory, that is a physical address or physical memory, or you say physical address space. Okay, properly बोलना है तो physical memory or physical address space. So in order to execute the process will be brought into physical address space. Okay, physical address. But okay, in order to execute any program, listen carefully. In order to execute any program, the CPU will always generate some address. In order to execute any program, the CPU will always generate some address. The CPU always generates logical address. Listen carefully. Okay, CPU always generates what? Logical address. Okay, now don't think about your doubts. Is that clear? So please remove your doubts. Okay, आपको क्या डाउट आता है, कहाँ पे आता है, किस लिए आता है, क्यों आता है, सब पता है. ओके, ऑल योर डाउट्स विल बी क्लैरिफाइड. ओके, थोड़ा पेशेंटली रखो, कोई डाउट पूछने की जरूरत नहीं है और बाहर सर्च करने की जरूरत नहीं है. ओके, सो एक स्टेप बाय स्टेप धीरे धीरे मैं इंक्रीज करूंगा, पूरा बताऊंगा. पूरा मेमोरी मैनेजमेंट ऑब्वियसली होगा 10 घंटे का तो टॉपिक होगा, राइट. सो एक ही घंटे में पूरा समझ में नहीं आएगा. ओके, जो भी तुम्हारा डाउट होगा आप अच्छे से लिख के रखो, ऑटोमेटिक क्लियर हो जाएगा नेक्स्ट 10 आवर्स में. अगर नहीं हुआ तो आप मेल करो मेरे को. समझ में आया सबको, राइट. ओके, प्लीज बी पेशेंट, राइट. ओके, सो कम बैक टू दिस. कहां पे आया था, राइट. So okay, in order to execute any process, the process will be brought into what? Main memory. Okay, that is the physical address space. In order to execute any process, okay, CPU will generate some address. Process को execute करने के लिए CPU कुछ address generate करता है, तो CPU will always generate which address? Logical address. Logical address. Okay, understand here. So CPU will always generate the logical address, but the actual process is available in the physical address. Now what the CPU is trying to do? CPU is trying to execute your process. What the responsibility of the CPU? Okay, CPU का okay रोल क्या है? CPU करता क्या है? Process को चलाना है, बस इतना ही है, right. So CPU is trying to execute your process. CPU is trying to execute your okay instructions of the process. Okay, where is the CPU process instructions are available? Where the process instructions are available? In the physical address space. Physical address space. Okay, so you can access them through physical address. Okay, physical address space. Okay, in order to execute any process, the CPU generating which address? Logical address. Now understand here, the problem here is the logical address will be different and physical address will be different. Understand here, what is the problem? The logical address will be different and physical address will be different. Okay, now okay, logical address मतलब CPU के पास कुछ अलग एड्रेस है और एक्चुअल इंस्ट्रक्शन कुछ अलग एड्रेस पे है. और CPU करना क्या चाह रहा है? CPU is trying to execute the instruction available in the physical address. CPU is trying to execute or CPU is trying to access the instruction available in the physical address. Okay, with the help of which address? उसके पास क्या एड्रेस है? लॉजिकल एड्रेस है. Now what is the problem? Problem here is logical address is different and physical address is different. Logical address is different and physical address is different. It means the CPU cannot directly access the instruction available in the physical address with the generated logical address. It is generating the logical address, right? So CPU cannot directly access the instruction available in the physical address with the generated logical address. Why? Because logical address is different and physical address is different. So there is a address mismatch. There's an address mismatch. So if you practically observe, practically क्या होता है मालूम? Practically logical address, okay, will be always greater to physical address. So practically logical address will be always greater to physical address. Okay, so ऐसा क्यों होता है वो सब समझ में आएगा. Okay, next classes में, okay, 3-4 दिन के बाद समझ में आएगा. ओके, ये सारे डाउट्स अच्छे से याद रखो, डाउट ऑटोमेटिक क्लियर हो जाएगा. राइट, सो आई एम रिपीटिंग. ओके, जस्ट फॉलो व्हाट आई एम सेइंग, प्लीज ब्लाइंडली फॉलो व्हाट आई एम सेइंग. ओके, एवरीथिंग यू विल अंडरस्टैंड. ओके, प्लीज लिसन टू मी. Right, so next I am coming from the first again. What is the problem here? The CPU cannot directly access the instruction available in the physical address with the generated logical address. Why? Because the logical address is different and physical address is different. There's address mismatch. So here we need some kind of mechanism. Here we need some kind of mechanism or a technique to map the CPU generated logical address to physical address. We need some kind of mechanism or a technique to map the CPU generated logical address to physical address. So the technique of mapping CPU generated logical address to physical address is called as what? Paging. Is called as paging. So what you are going to do in the paging? You simply map the logical address to physical address. Okay, so what you are going to do in the, okay, what you are going to do in the okay, in the paging, what you will do? You simply map the logical address to physical address. So that technique of mapping the CPU generated logical address to physical address is called as what? Paging. Is that clear for everyone? Right, so how you are going to map that, okay, logical address to physical address? So the technique, okay, concept we are going to study now. Now understand here, अभी तक मैं जो भी एक्सप्लेनेशन बताया, इतना सारा जो भी बताया, ओके, लास्ट 10 मिनट्स, एंड यू विल हैव 2 डाउट्स. आपको 2 डाउट होता है. सो फर्स्ट डाउट ये होता है, व्हाई CPU जनरेट्स लॉजिकल एड्रेस. दैट्स द फर्स्ट योर डाउट. And second doubt, why logical address is greater to physical address. So these 2 are your doubts. Remember, these 2 doubts will be clarified when I discuss the virtual memory, maybe after 3 sessions or 4 sessions depending on the time and all that. So when I discuss the virtual memory, I'll clarify all that. So no need to refer anything or any searching mail not required. Automatically you will understand everything. So please follow the class, okay, blindly. Is that clear for everyone? Right. So now understand here, okay, one interesting point again. Now what I said here, okay, CPU will always generate which address? क्या बोला था? CPU will always generate which address? Logical address. Very good. So logical address generate करेगा. Now remember, when you study computer organization, okay, maybe you study after OSR, कभी तो पढ़ोगे ना, right? When you study computer organization, okay, CO teacher will tell you, okay, just wait. Okay, so when you study computer organization, okay, the CO teacher, okay, computer CO sir will tell you the CPU always generates physical address. Listen carefully. So CO teacher क्या बताएगा? CPU always generates physical address. Remember, okay, CO में ऐसे ही पढ़ना है. CO में क्या बताओ? CPU always generates physical address. CO में ऐसे ही पढ़ना. OS में क्या पढ़ना है? CPU always generates logical address. Okay, OS में ऐसे ही पढ़ना है. So OS में ऐसे ही पढ़ना है. Okay, CO में ऐसे ही पढ़ना है. But actually what is actually practically correct? Okay, practically what actually correct is, बताओ, OS is correct. Okay, right? So practically what is correct? OS is correct. CPU always generates what? Logical address only. Is that clear? So practically OS is correct. Okay, so CO teacher ऐसा क्यों बोलता है फिर? CO teacher ऐसा क्यों बोलता है? Okay, CO आप पढ़ेंगे तो CO teacher will tell you CPU always generates physical address. So CO में ऐसा क्यों बोलता है CO teacher? Because in the CO you will not study the concept of virtual memory. Okay, in the CO there is no concept of virtual memory. In the CO you concentrate more on the cache memory, cache mapping techniques, okay, like okay, associative mapping, set associative mapping, direct mapping. Okay, you study all that. You concentrate more on the cache memory and all that, cache memory mappings and all that. So that is the reason, okay, so CO you will not study the concept of virtual memory. So that is the reason CO, okay, you say CPU always generates physical address. But OS, okay, you always study CPU always generates, okay, virtual address. Logical address or virtual address, both are same only. Is that clear? So why CPU generates logical address? Okay, why? Because Understand, you proper reason you will understand after 4 days. I told you, nowadays in all our computers, whatever the computer we are using, your laptop and my laptop, every laptop is having what? Virtual memory. In all our modern operating systems, whatever we use, we maintain virtual memory. Without virtual memory, there is no computer. Is that clear? So that is the reason. Practically, what is correct is CPU always generates okay, virtual address or it's a logical address. Both are same only. Right. So ऐसा क्यों होता है? Okay, actual reason. Okay, you'll understand after 3-4 days. Okay, so please maintain. Okay, please be patient. Right. So I'm repeating. Okay, so what is the important point? Why we are, what we are going to do in the paging? First of all, why we are going for paging? ये point to clear है. Why we are going for paging? Because CPU generating logical address and actual instruction is available in the physical address. What is the problem? The CPU cannot directly access the instruction available in the physical address with the generated logical address. Why? Because there is a address mismatch. Logical address is different and physical address is different. So here we need some kind of mechanism or a technique to map the CPU generated logical address to physical address. Is that clear? So that is the reason, okay, we are going for paging. And in the paging, what we are going to do? We are going to simply map the technique of mapping the CPU generated logical address to physical address is called as what? Paging. Is that clear? Note down this point. Please make a notes. Note down this point. Note down the technique of mapping. Note down the technique of mapping CPU generated. The technique of mapping CPU generated logical address to CPU generated logical address to physical address. CPU generated logical address to physical address is called as paging. Is called as paging. Okay, right. So how we are going to implement paging? So that concept we are going to study now. Okay, right. So understand carefully. Next. Okay. So I am assuming, okay, the answer is not just say. So I am assuming logical address. Logical address is okay 13 bits. Logical address is 13 bits and physical address is 12 bits. Okay, copy karo. Okay, you have to take the running notes. Okay, you have to take the running notes. Now understand carefully. So the answer is not just say, okay, logical address कितना है बताओ? Logical address 13 bits. Physical address कितना है बताओ? 12 bits. Okay, look at here. Logical address is greater than physical address. Okay, we are following. Okay, that is there. Now how you are going to map? How you are going to map this? Okay, 13 bits logical address to 12 bits physical address. The technique we are going to study now. The technique we are going to study now. Is that clear for everyone? Right? Now remember the concept will take around 1 hour, 1 hour 10 minutes depending on that. So okay, it will take around 1 hour. The answer is not the same. Okay, the concept will take 1 hour. So after my concept, after my explanation, you are going to solve the questions. Okay, you will solve around 6 to 7 or 8 questions including your previous gate questions. Okay, remember the target is to solve the questions only. If you follow my concept, you can solve all the questions. If you follow my concept, you can solve all the questions. Is it clear? Right, remember, okay, target is to solve the questions. Okay, so follow carefully and copy everything carefully and make the running notes. I will dictate. Okay, I will dictate and I will tell you what to copy, what not to copy and everything. So okay, take the running notes, listen carefully, उसके बाद आप problem solve करोगे. Is it clear? Target is to solve the problems only. I will explain only concept. Okay, and all the questions you are going to solve. Remember, you can solve all the questions if you follow the concept carefully. Is that clear for everyone? Right. Okay, so maintain smile. So listen carefully. So copy किया इसको, right. Okay, so logical address 13 bits. अब बताओ logical address अगर 13 bits है, okay, now tell me logical address space. Logical address space कितना होगा? हाँ बताओ, logical address space 2 power 13. 2 power 13. Okay, words. I am assuming word addressable memory. So 2 power 13 words. मतलब कितना होगा इसका वैल्यू? 8 किलो वर्ड्स. 8 किलो वर्ड्स. Okay, right? So 2 power 3 matlab 8, 2 power 10 matlab kilo, right? 8 kilohertz. PA is, I am assuming word addressable memory. I assume kiya word addressable memory, right? So PA is a 12 bits. Okay, now tell me PAS kitna hoga? Okay, PAS will be how much? Okay, LA is okay, this is okay 8 kilohertz ho gaya. So PA 12 bits hai, to PAS kitna hoga? 2 power 12 words. So that is the 4 kilohertz. 4 kilohertz. So is that clear for everyone? Right? Okay. Okay, fine. So that is a okay. PS is a okay 4 kilohertz. Now, so logical address LAS कितना है बताओ 8 kilohertz. PS is a 4 kilohertz. So please copy this. So logical address space. Okay, LAS is a 8 kilohertz. Okay, so this is PS. PS is a 4 kilohertz. Okay, copy this. Take the running notes. Okay, simultaneously. Okay, running notes में copy करो. Logical address space 8 kilohertz and PS is a 4 kilohertz. copy किया ना सब लोग? Right. Okay. ये थोड़ा क्रॉस हो गया क्या? Okay, right. So understand here. Next, now the answers to know next. Okay, logical address space. Just listen carefully. Logical address space कितना है बताओ? 8 kilohertz. Logical address space LAS. Listen carefully. Logical address space LAS is divided into equal size pages. Okay, the concept is what? LAS is divided into what? Equal size pages. Okay, look at here, equal size pages. Okay, copy karo. Next statement likho. Note down. LAS logical address space is divided into equal size pages. Logical address space is divided into equal size pages. Okay, now understand here, I am assuming page size. Okay, I am assuming page size equal to 1 kilowords. Okay, no doubt. Take the running notes. थोड़ा slow बता रहा हूँ. Okay, so the answer is not the same. Okay, I am assuming page size equal to 1 kilowords. Okay, right? So I am repeating, LAS is going to what? Equal size pages bola. LAS is going to equal size pages bola, and the page size I am assuming as what? 1 kilowords. Now tell me, if I assume page size as 1 kilowords, now if I divide LAS into equal size pages, if I divide the LAS into equal size pages of size 1 kilowords, then how many pages will get? How many pages will get? 8. 8 pages will get. Now if you want to find out number of pages, okay, no down the formula. Number of pages अगर आपको निकालना है तो formula क्या है बताओ? LAS divided by page size. No down. LAS divided by page size. Okay, so that is 8 kilowords divided by 1 kilowords, that is 8. So copy करो. Okay, number of pages अगर आपको निकालना है, so LAS divided by page size. So number of pages formula. Okay, डब्बा में लगाओ. डब्बा means important. Okay, understand here. So I write here, LAS will be divided to equal size pages. Okay, 8 pages जैसा हो जाएगा. So now this divided to 8 pages. Copy this. Okay, equal size pages like this. Okay, so 0, 1, 2, 3, 4, 5, 6, 7. Okay, so this is the page, and every page is having how much size? 1 kilowords. So this also again 1 kilowords. Okay, so this also again 1 kilowords. Okay, so every page is how much size? Every page is having 1 kilowords. So what is this here? So this is the page number. So this is the page number. Okay, so these are the pages. Okay, so page 0, 1, 2, 3. Okay, the other pages. Okay, copy all this. Page number. Number means I am writing hash. Hash means number. Okay. Now understand here. Okay, I am asking the question. In the LES, you are having how many pages here? LES में कितना pages है? 8 pages है. To represent to represent all the 8 pages of LES. बताओ सोच के. To represent all 8 pages of LES, how many binary bits are required? 8 pages है. 8 pages को represent करने के लिए how many binary bits are required? 3 binary bits required. Okay, उतना सोच रहे हैं कुछ लोग. Right, 3 binary bits था. कैसे? 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1. Okay, 0 1 1 1 0. Okay, 1 1. Okay, so copy करो. So if you are having 8 pages, then to represent every page, you require the 3 binary bits. So like okay, all zeros to all ones. Okay, right. So understand carefully. So that is about okay, LES. Now LES is having okay 8 pages. To represent all the 8 pages, you require 3 binary bits. Now I am asking the question. The answer सुनो जैसे if you are having 8 pages, बताओ 8 pages है. To represent all the 8 pages, how many bits required? 3 bits required. Now in the same manner, if you are having 512 pages, how many bits required? 512 pages है तो कितना bits चाहिए? 9 bits चाहिए. In the same manner, if you are having 1024 pages, how many bits required? 10 bits required. If you are having 1k pages, if you are having 1k pages, how many bits required? Same only. 1024 मतलब 1k, so 10 bits only, right? Now tell me, let's say if you are having okay, सोच के बताओ, if you are having 32 kilo pages, how many bits required? Okay, 8 pages है तो 3 bits चाहिए, 512 pages है तो 9 bits चाहिए, 32k pages है तो कितना bits चाहिए? 2 power 5, 2 power 10. माइंड में कैलकुलेशन हो जाना, कल का क्लास क्या पढ़े पता नहीं, राइट? सो 2 power 5, 2 power 10 कितना बिट चाहिए? 15 बिट चाहिए. सो नेक्स्ट, नाउ टेल मी, तो जोर से बोलो, राइट? इफ आई एम हैविंग 256 मेगा पेजेस, हाउ मेनी बिट्स रिक्वायर्ड? 256 mega pages, how many bits required? 2 power 8, 2 power 20, 28 bits required. Is that clear? And next, if I am having 64 giga pages, how many bits required? 64 giga pages, how many bits required? Okay, 2 power 6, 2 power 30, 36 bits required. If you are having let's say 512 tera pages, how many bits required? How many bits required? 2 power 9, 2 power 40, that is 49 bits required. Is that clear? So these are all required while solving the problems. Okay, ये सारे आपको मालूम होना चाहिए ऐसा. Okay, कॉपी मत करो इसको, not required. Okay, इसको कॉपी नहीं करना. Okay, so is that clear? Right. Okay, so 8 pages है, you require the 3 binary bits. Okay, so understand here. And next, now coming to the okay PAS, physical address space. Listen carefully. Physical address space is divided into equal size frames. Okay, equal size frames. Okay, understand? Note down next point. Physical address space, please make a note. Physical address space, PAS, physical address space is divided into physical address space, PAS is divided into equal size frames. PAS is divided into equal size frames. Is that clear? Right. So understand here, PAS is divided into equal size frames. Okay, I am assuming okay, generally, okay, understand here. So okay, what we assumed here? Okay, अपन क्या assume किया? Page size equal to 1 kilohertz assume किया. Then सुनो next point, page size will be always same as frame size. Page size will be always same as what? Frame size. Whatever the page size you are having, that will be exactly same as what? Frame size. Okay, no doubt. Next point, ये भी लिखो. Page size is always same as frame size. Okay, so understand here. So you can just copy this also if you want. So I am writing clearly in the box, page size is equal to frame size. So whatever the page size you are having, that is always same as what? Frame size. Okay, So now tell me page size how much we assumed here, okay, 1 kilohertz. If the page size is 1 kilohertz, then frame size also what? Frame size also 1 kilohertz. So okay, now tell me PS is a 4 kilohertz, PS is a 4 kilohertz here. If I divide that into okay equal size frames of 1 kilohertz, then how many frames you will get? कितना फ्रेम्स आएगा? 4 फ्रेम आएगा. ओके, सो नंबर ऑफ फ्रेम्स निकालना है तो फॉर्मूला क्या होगा? ओके, नोट डाउन नंबर ऑफ फ्रेम्स इक्वल टू, बताओ व्हाट इज द फॉर्मूला? PAS डिवाइडेड बाय फ्रेम साइज. PAS डिवाइडेड बाय फ्रेम साइज. ओके, सो प्लीज कॉपी प्रॉपरली. नंबर ऑफ फ्रेम्स निकालना है तो PAS डिवाइडेड बाय फ्रेम साइज. ओके, PAS कितना है अपना? 4 किलोवाट्स. फ्रेम साइज कितना? 1 किलोवाट्स. दैट इज हाउ मेनी फ्रेम्स? 4 फ्रेम्स. Make the proper copy, right? So number of frames equal to PAS divided by frame size. So PAS is a 4 kilowatts and okay, frame size both are same, 1 kilowatts. Number of frames will be 4. So copy karo, copy this. Okay, so you are going to have the 4 frames in the PAS here like this. So 0, 1, 2, 3. Okay, so understand here. So this is the okay frame number. Okay, so this is a frame number. Now tell me to represent all the frames of PAS. कॉपी किए सब लोग? कॉपी करो, डिवाइड करो. ऑलरेडी कॉपी किए थे ना, उसी के ऊपर डिवाइड करो. ऑलरेडी कॉपी किया ना, उसी के ऊपर डिवाइड करो बस. हाँ, नाउ टेल मी. So PS you want to 4 frames here. Okay, so to represent all the 4 frames, how many binary bits are required? How many binary bits are? 2 binary bits. So that is a 0 0 0 1 1 0 1 1. Okay, is that clear for everyone? Okay, right. So that is about the okay frames. Okay, right. So next understand carefully. Next point, the answers know. Okay, in the LES you are having 8 pages. Okay, this is a page number 0, page number 1, 2, 3 like this. And in the PS you are having 4 frames. Now remember, okay, sum of the pages of LES. Next point, the answers no. Sum of the pages of LES will be brought into PAS. So sum of the pages, whatever the page you are having here, 8 pages are there. So sum of the pages of LES will be brought into PAS. Okay, make a note of this. No doubt. Next point, sum of the pages of LES. Sum of the pages of LES will be brought into Sum of the pages of LES will be brought into PAS. Sum of the pages of LES will be brought into PAS. Okay, right. So understand here, some of the pages of LES will be brought into PAS. Now some of the pages randomly. Okay, let's say page number 7. So I'm bringing page number 7. Okay, so into frame number 0. Next page number 5. Let's say page number 3. And next page number 1. Okay, so some of the pages of LES okay will be brought into what? PAS. Okay, right. So like that. Next okay, copy करो उसको. copy किए? Already copy किया था ना, इसमें fill करो बस. Page number 7, 5, 3, okay, 1, something like this. Okay, छोटा छोटा अगर डाउट है, कुछ भी डाउट है तो लिख के रखो, ऑटोमेटिकली क्लियर होगा. ओके, 3-4 दिन वेट करना पड़ेगा सारे कॉन्सेप्ट पूरा फिनिश होने के लिए. राइट, सो अंडरस्टैंड हियर. So some of the pages of LES will be brought into what? Okay, PAS. Okay, so remember what are the page you are having, you are bringing that into okay frames here. Okay, now remember that is the reason the page size will be always same as what? Frame size. That is the reason the page size will be always same as what? Frame size. It means what? Whatever the page you are having, that will automatically fit in the frame. Okay, so that is the reason. Okay, अपन ऐसा करना चाह रहे हैं. So that is the reason page size will be always same as what? Frame size. Is that clear? Right. So next, now tell me what is the page size as assumed here. Okay, what is the page size we are having? Page size is 1 kilowatts I assumed. Okay, look at here. Okay. Next, listen here. So, okay, right here. actually board is small, so that is the reason. So logical address we assumed 13 bits and physical address is 12 bits. बताओ page size, how much we assumed page size? 1 kilowords. Okay, now we assumed page size as 1 kilowords. Okay, now where is the page size? Page size diagram में बताओ, where is your page? 1 kilowords page कहाँ पे? Okay, this is the 1 kilowords of page, 1 kilowords. Every page is having how much size here? 1 kilowords. लिखा है इतना अच्छा. Every page is having how much size? 1 kilowords of size, and same page is brought into PAS. So this is also page, मतलब frame के अंदर page है, exactly. So frame के अंदर page है, so frame size भी 1 kilowords ही है. So okay, every page okay is having 1 kilowords of size. What is the meaning of 1 kilowords of page? Understand that point. Okay, so listen carefully. So copy this, copy करो. Page size we assumed as 1 kilowords. So page size we assumed as 1 kilowords. So when I assume page size is 1 kilowords, what is the meaning of that? Okay, listen here. So this is how the page will look like. So the page is going to have 1 kilowords. 1 kilowords. 1 kilowords means what? 2 power 10. So copy karo, copy this. The page will look like this. Okay. So like this, okay, we are going to have 0, 1, 2, 3, 4, 5, 6. Okay, now tell me 0 to okay 2 power 10 minus 1. Okay, 1 kilo matlab 2 power 10. So 0 to 2 power 10 minus 1. So these are okay. These many words will be there in the page. Okay, copy karo. Copy here, right? So this is a 1 kilowords of a page. Okay, so you are having a total okay 2 power 10 words. So मैं किसका बात कर रहा हूँ बताओ? डायग्राम में कहाँ पेज है? Okay, मैं रिपीट कर रहा हूँ. Okay, this is the page. Okay, right. So डायग्राम में कहाँ है? Okay, this page. Okay, every page is having 1 kilowords. Okay, इसका मतलब इसके अंदर okay in this page. Okay, इसके अंदर कितना वर्ड्स है? 1 kilowords है. 0, 1, 2, 3, 4, okay, like this 2 power 10 minus 1, 0 to 2 power 10 minus 1. So 1 kilowords है इसके अंदर, right? Now what is going to happen is, listen carefully, inside this every word of the page, inside this every word of the page, we are going to have the actual instruction of the process. Okay, now look at here, like instruction I1, okay, I2, I3, I4, okay, I5, I6, I7, okay, I8, like this. Inside this every word you will have the actual instruction of the process. यहाँ पे लिख रहा हूँ. So that is the actual instruction of the process. Actual instruction of the process. कॉपी करो आप लोग अच्छे से. So inside that every word you will have the actual instruction of the process. Copy किए, right? Now tell me, okay, look at here. So it's a instruction I1, I2, I3, okay, actual instruction of the process. Now total how many words are there here? How many words are there here? 2 power 10 words are there. Now tell me, to represent every word of the page, to represent every word of the page, how many binary bits are required? How many binary bits are required to represent every word of the page? Okay, how many binary bits are required? Copy किए थे ना इसको already, right? मैं हटा दे रहा हूँ, space नहीं है. To represent every word of the page, how many binary bits are required? 10 binary bits are required. Like this, how? Okay, 0, 0, 0. Okay, look at here. So all zeros to all ones. Okay, simple, right? Okay, so understand here. So this is a 0, 0, 0, 0, 0. Okay, 0, 0, 0, 0, 1. And next 0, 0, 0, 0, 0, 0, 0, 0, 1. Okay, this is 1, 0. Is that clear? Right. So next is what? Okay, 1, 1. Next is okay, 1, 0, 0. Is that clear? 1, 0, 1. Okay, so like this, okay, like this, we are going to have last one is what? All ones. Okay, copy karo, please copy this. Oh sorry, this is 0. Okay, printing mistake ho gaya. First one is all zeros, right? Okay, all zeros, 0, 0, 1. Okay, sorry. Okay, all zeros, all 0, okay, next 0 0 1, so next 1 0 1 1, so like this, okay. So we are going to have all ones. First one is the all zeros only, right. Printing mistake हो जाता है, अच्छे से सुनो, correction कर लो, छोटा छोटा printing mistake हो गया था, right. Okay, so all zeros to all ones, समझ में आया सबको, right. So repeat कर रहा हूँ, you are having page size कितना है बताओ, 1 kilowords. To represent 1 kilowords of page, okay, to represent 1 kilowords of page, how many binary bits are required? To represent 1 kilowords of page, how many binary bits are required? 10 binary bits are required. Now tell me, if the page size, okay, look at here, page size is 8 kilowords, how many binary bits required? Page size 1 kilowords है तो 10 binary bits required. If the page size is 8 kilowords, how many bits required? 13 bits required, okay. If the page size is 8 kilobytes, how many bits required? To represent every word or every byte, how many bits required? Same, 13 bits only. This is just a representation, उसको कुछ भी करने का नहीं है, right. So 8 kilo, 2 power 3, 2 power 10, 13 bits. If the page size is, okay, look at here, page size is 16 megabytes. Now tell me, how many bits required? 16 megabytes, 2 power 4, 2 power 20, 24 bits required. Now tell me if the page size is, okay, 64 gigawords, how many bits required? Page size is 64 gigawords, how many bits required? 2 power 6, 2 power 30, that is 36 bits required, 36 bits required. Is that clear for everyone? Right. So no need to copy this, okay, इसको copy मत करो, right. हाँ, ये वाला कॉपी किया ना सब लोग अच्छे से, ओके, ये वाला कॉपी किया सब लोग, राइट, ओके. सो आई एम रिपीटिंग वंस अगेन, लास्ट पेज साइज 1 किलोवर्ड्स है, ओके, व्हेनेवर ऐसे पेज साइज 1 किलोवर्ड्स है, ओके, वो पेज के अंदर 1 किलोवर्ड्स है, 1 किलोवर्ड्स है, ओके. सेम थिंग हियर आल्सो, और एक पेज के अंदर 1 किलोवर्ड्स है, 0 1 2 3 4 0 to 2 power 10 minus 1 टू रिप्रेजेंट एवरी वर्ड ऑफ द पेज. ये पेज के अंदर जो हर एक वर्ड है उसको रिप्रेजेंट करने के लिए, उसको एक्सेस करने के लिए, उसको आइडेंटिफाई करने के लिए, उसको पकड़ने के लिए कितना बिट चाहिए? 10 बिट चाहिए, 10 बिट चाहिए. ऑल zeros to all ones. Is that clear for everyone? Right. So that is the meaning of page size. Next. Okay. So next point, okay, understand here. Next, whenever the paging is applied, listen carefully. Whenever the paging is applied, the page table has to be maintained. Whenever the paging is applied, what you have to do? The page table has to be maintained. See, applying paging means what? Applying paging means dividing something into pages. Applying paging means what? Dividing something into pages. So यहाँ पे किसके ऊपर paging किया, किसको divide किया अपन? alias को divide किया. So applied, okay, divided the alias into what? Pages. So whenever the paging is applied, you need to maintain the page table. No doubt. Next point. लिखो, notes में लिखो. Whenever the paging is applied, the page table has to be maintained. लिखो अच्छे से. Whenever the paging is applied, the page table has to be maintained. Okay. So whenever the paging is applied, the page table has to be maintained. Okay. So how the page table will look like? Okay, understand here. So जब भी paging करते हैं तो you need to apply paging. Page table will be maintained. So I am writing here, the page table will look like this. Okay. So let's say you are having page table here. Okay. Okay. So this is the page table. Okay. This is the page table. So please copy this. So page table will have some entries here. So 0, 1, 2, 3, 4, 5, 6. 7. So this is the page table. Okay, and remember this is called as a page table entry. page table entry. In the question sometimes say PTE, okay, right, page table entry. Please copy this. I will explain all that. Okay, so 0 1 2 3 4 5 6 7, so this is the page number. Copy here सब लोग, right? Okay, so understand here. So if you are not copied, so please pause my video, right? Okay, running notes लिखो, running में copy करो, running में continuation में ही लिखना, okay सब, okay पूरा अच्छे से notes बनाओ, पूरा अच्छे से notes बनाओ, right? Now I am repeating, whenever the paging is applied, the page table has to be maintained. Okay, so it is a page table. Okay, understand here. ये पेज टेबल देखते ही कुछ इंपॉर्टेंट पॉइंट समझ में आना चाहिए. दिस पेज टेबल इज हैविंग हाउ मेनी एंट्रीज, कितना एंट्रीज है देखो यहाँ पे 0 1 2 3 4 5 6 7. ओके, टोटल हाउ मेनी एंट्रीज आर देयर 0 to 7 total 8 entries are there. Okay, so why you are having 8 entries? First of all, this is a page table entry, right? लिखा है इतना अच्छा. So this is a page table entry. Why? How many entries are there? 8 entries are there. So why you are having 8 entries in the page table? Because that is same as number of pages in the LEAS. Number of pages in the LEAS. Okay, so number of entries in the page table. Number of entries in the page table is same as number of pages in the LEAS. Number of pages in the LEAS. Is that clear? Note down this pointer. Note down number of entries. Now understand here. Note down number of entries in the page table. Note down number of entries in the page table is same as number of entries in the page table is same as number of pages in the LEAS. Number of entries in the page table पूरा लिख रहे हैं ना. Number of entries in the page table is same as number of pages in the LEAS. Number of pages in the LEAS. Okay, right? Keep that in a box. Okay, उसको डब्बा में लगाओ. Okay, जो पॉइंट लिखे था ना डब्बा में लगाओ. डब्बा मीन्स इंपॉर्टेंट पॉइंट. ओके, डब्बा बोलते हैं आप लोग, डिब्बी बोलते हैं, डिब्बी डब्बा, राइट, वॉट एवर. Okay, right. So understand it. So number of entries in the page table same as number of pages in the LEAS. Now, so these are the number of entries. Okay, you are having 8 entries are there, the same as number of pages. Now this is your page table entry. Understand here, page table entry के अंदर क्या होता है, page table entry के अंदर क्या होता है, just listen carefully. Page table entry, okay, definitely contains, सुनो पहले मैं नोट्स देता हूँ. Page table entry definitely contains a frame number, but sometimes it may also contain additional bits. Okay, but page table entry definitely contains what? Frame number. Okay, now it means कौन सा पेज कौन सा फ्रेम है. Now tell me page number 0 here, this is a number. Okay, page number है, page number 0 कोई फ्रेम के अंदर है, यहाँ पे पेज नंबर 0 कोई फ्रेम के अंदर अवेलेबल है, पीएस में नहीं है, तो यू विल हैव ए ब्लैंक, दैट इज नॉट देयर. पेज नंबर 1 कोई फ्रेम के अंदर है, यस, फ्रेम नंबर ओके 3. So frame number 3 you write in the binary format. Okay, that is 1 1. Okay, binary format. So page number 2 okay not there, कोई भी फ्रेम में नहीं है, पेज नंबर 2 कोई फ्रेम में नहीं है, तो you will have blank. पेज नंबर 3 कौन सा फ्रेम है, पेज नंबर 3 फ्रेम नंबर 2 में है. रिमेंबर एवरीथिंग इज अ बाइनरी रिप्रेजेंटेशन ओनली. यहाँ पे जो नॉर्मल डेसिमल लिखा है जस्ट फॉर आवर अंडरस्टैंडिंग ओनली, बट इन द मेमोरी ओके एवरीथिंग इज अ बाइनरी ओनली, राइट. ये डेसिमल जो लिखा है अपने अंडरस्टैंडिंग के लिए लिखा है, राइट. हाँ बताओ, पेज नंबर 3 फ्रेम नंबर 2 में है, सो दैट इज अ 1 0. एंड पेज नंबर 4 नहीं है, पेज नंबर 5 ओके 0 1, पेज नंबर 7 6 नहीं है, ब्लैंक 6 नहीं है, ब्लैंक. पेज नंबर 7 ओके फ्रेम नंबर 0. ओके, पेज नंबर 7 फ्रेम नंबर 0 में. Is that clear? Right. Okay, understand here. So this is the okay page table you are having. Page table entry contains what? Frame number. Okay, इसको कॉपी करो, पहले इसको कॉपी तो करो अच्छे से, मैं नोट्स देता हूँ. ओके, कॉपी करो, कॉपी दिस. Okay, note down page table entry, note down the statement. page table entry definitely contains, no doubt, page table entry definitely contains frame number. Page table entry definitely contains frame number. Okay, full stop. So keep that in a box. उसको भी डब्बा में लगाओ, अच्छे से बॉक्स में लिखो. Right? So important point है. Right? So page table entry definitely contains frame number. Okay, understand here. Okay, next important point. Listen here. Page table. Okay, copy करो. Continuation में copy करो आप लोग. So page table is also called as address translation table. Address translation table. Okay, so sometimes in the question you will use this term. Okay, don't confuse. No doubt. Page table is also called as लिखो. Page table is also called as address translation table. And next, sometimes frame number. Okay, look at here. Frame number is also called as translation bits. Frame number is also called as translation bits. Frame number is also called as translation bits. Okay, इसको याद रखना है. Okay, in the different question they use a different name. Okay, so कभी address translation table बोला है तो इसका मतलब page table only. Translation bits बोला है, that is a frame number only. Okay, so okay, you need to remember. Okay, हटा दो इसे. कॉपी किया? Right. Okay, so that you should remember. Next, now understand here. Okay, that is about page table. So is all that clear? Right. Next, what I said here, CPU always generates what? Logical address. I told you clearly, CPU always generates logical address. Now understand here. So I am writing here. Okay, logical address we assumed 13 bits. Physical address we assumed 12 bits. And page size is 1 kilobytes. Okay, understand here. Okay, so the answers now just say next. Okay, I told you CPU always generates a logical address. So let's say we are having the CPU here. Okay, we are having CPU. CPU always generates a logical address. Okay, look at here. So here is the CPU. CPU always generates a logical address. Okay, that is logical address कितना assume किया? 13 bits assume किया. Copy करो, copy this. So CPU, okay, always generates logical address. So P means what here? Processor. Processor always generates a logical address. Copy करो इसको. Continuation में लिखो आप लोग पूरा डायग्राम बाद में कॉपी करेंगे, राइट? पहले continuation में इसको लिखो, बस इतना ही. CPU always generates a logical address. Okay, so look at here. Logical address कितना assume किया बताओ अपन? 13 bits assume किया. So P मतलब क्या बताओ? Processor. Processor always generates logical address. Copy that. Okay. So the answer is next. CPU always generates logical address. So P means processor. Okay. Now understand here. Next. Okay. You are having logical address कितना assume किया? 13 bits. The 13 bits of logical address is divided into two parts. Listen here. 13 bits of logical address divided into two parts. Okay, that is P and D here. 13 bits logical address divided into two parts, that is P and D. So what is the meaning of P and D? Okay, let's try to understand. So 13 bits logical address divided into two parts. Okay, so I am changing. Okay, divided into two parts. Okay, P and D. So what is the meaning of P and D? Okay, listen here. What is the meaning of P and D? Note down. P equal to लिखो, नेक्स्ट लाइन में लिखो, कंटिन्यूएशन. P इक्वल टू नंबर ऑफ बिट्स रिक्वायर्ड, number of bits required to represent pages of LAS. Number of bits required to represent pages of LAS or page number. Okay, ऐसा लिखो. Okay, look at here. Number of bits required to represent pages of LAS. Okay, or ऐसा लिखो, or page number. Okay, right. Now tell me, okay, how many pages are there in the LAS? LAS में कितना pages है? 8 pages है. to represent 8 pages how many bits are required? 3 binary bits are required. इसका मतलब पेज नंबर के लिए कितना बिट चाहिए? 3 बिट्स चाहिए. सो इसका मतलब अगर आपके पास 3 बाइनरी बिट्स है, यू कैन एक्सेस एनी पेज, कोई भी एक पेज को आप एक्सेस कर सकते हो, सिंपल सी बात है, राइट. सो ओके, पेज नंबर रिक्वायर्स 3 बिट्स. ओके, दैट इज अबाउट पी. ओके, नो डाउट. नेक्स्ट इज व्हाट हियर? डी. नो डाउट. डी इक्वल टू, नो डाउट, नेक्स्ट लाइन में लिखो डी इक्वल टू ओके, number of bits required, d equal to number of bits required to represent page size. okay, number of bits required to represent page size. ऐसा लिखो पूरा अच्छे से. number of bits required to represent page size, और इधर सुनो, number of bits required to represent page size, और ऐसा लिखना है, और word number of the page, or word number of the page, word number of the page, and one more r, word number of the page हो गया, one more r, it is also called as one more r, page offset. okay, it is also called as what? Page offset. Page offset. okay, so meaning of all that is same only. okay, copy किया सब लोग, right. So meaning of all that is same only, right. So I am repeating. okay, understand here. So what is D here? D will tell you what? Number of bits required to print page size. okay, now tell me what is the page size we assumed here? Page size कितना है? 1 kilowords. Now to represent every word of the page, how many binary bits are required? 10 बाइनरी बिट्स आर रिक्वायर्ड. ऑलरेडी बताया था, पेज को पूरा ड्रा करके दिखाया अच्छे से. ओके, पेज के अंदर 1 किलो वर्ड्स है, 2 पावर 10 वर्ड्स है. हर एक वर्ड को एक्सेस करने के लिए कितना बिट चाहिए? 10 बिट चाहिए. सो इसलिए डी के लिए कितना बिट्स होगा? 10 बिट्स होगा. डी के लिए 10 बिट्स होगा. इज इट क्लियर? सो दैट इज अबाउट व्हाट? लॉजिकल एड्रेस. एंड नेक्स्ट, नाउ कमिंग टू द फिजिकल एड्रेस. सो व्हाट इज द मीनिंग ऑफ फिजिकल एड्रेस? ओके, जस्ट लिसन हियर. सो कॉपी दिस. फिजिकल एड्रेस कितना अज्यूम किया अपन? फिजिकल एड्रेस कितना है बताओ? 12 बाइनरी बिट्स. So copy this. Physical address is 12 bits. So physical address, okay, अपना physical address कितना है? 12 binary bits है. So 12 bits of physical address. Physical address 12 bits is divided into 2 parts, that is F and D. okay, copy करो. Copy this carefully. right, इसको copy करो सिर्फ. Now tell me. So physical address is 12 bits. We assumed. okay, physical address 12 bits यहाँ पे, and 12 bits of physical address to F and D. what is the meaning of F and D? okay, note down. F equal to, continuation में लिखो अच्छे से. F equal to number of bits required to represent, number of bits required to represent frames of PAS. number of bits required to represent frames of PAS. number of bits required to represent frames of PAS. okay, or next, or okay, frame number, number of bits required to represent frames of PAS or frame number. okay, now tell me how many frames are there in the PAS? in the PS how many frames are there? okay, 4 frames are there. So okay, you are having 4 frames here. To represent the 4 frames how many bits are required? 4 frames को रिप्रेजेंट करने कितना बिट चाहिए? 2 बिट चाहिए. इसलिए सो ऑलरेडी है ना यहाँ पे. सो एफ के लिए कितना बिट चाहिए? 2 बिट्स चाहिए, राइट. नेक्स्ट इज व्हाट हियर? डी. व्हाट इज द मीनिंग ऑफ डी? ओके, नोट डाउन. डी इक्वल टू लिखो अच्छे से. डी इक्वल टू नंबर ऑफ बिट्स रिक्वायर्ड टू रिप्रेजेंट फ्रेम साइज. number of bits required to represent frame size. okay, so number of bits required to represent frame size, or word number of the frame. यहाँ पे लिख रहा हूं, ऐसा लिखो. word number of the frame. and one more r is what? it is also called as a frame offset. word number of the frame, or say frame offset. okay, fine. So meaning of all this is the same only. okay, right, copy किए. right? Okay, so fine. Now understand here. Okay, the answer is number of bits required to prevent the frames of PA. Okay, what is that? D के लिए क्या लिखे? Number of bits required to prevent frame size. Now tell me what is the frame size here? Frame size, page size, both are same. Is that clear? Word number inside the page, word number inside the frame, both are same, because number of words in the frame, number of words in the page, both are same only. Okay, because page size, frame size, both are same. So बताओ, okay, frame size भी 1 kilowords है, तो how many bits are required? 10 bits are required. Okay, 10 bits are required. Is that clear? So 10 लिखो यहाँ पे, right? Okay, so next, so I am going to connect the diagram. Okay, just listen here, listen carefully. So what is the meaning of this? Let's try to understand. The answer is no. Okay, next, I am going to connect the diagram. पहले सुनो अच्छे से, कॉपी मत करो, लास्ट में कॉपी करोगे अच्छे से, फिर डायग्राम लास्ट में कॉपी करोगे आप. Okay, listen first. Now CPU always generates logical address बोला, right? So CPU always generates logical address. In the logical address divided into two parts, P and D. Logical 13 bits है. Okay, that's divided to 2 and okay, P and D. So P के लिए कितना bits है? 3 bits है. Now let us say CPU is trying to access. Okay, the answer सुनो अच्छे से. लॉजिकल एड्रेस डिवाइड टू टू पार्ट्स. ओके, पी एंड डी. इसका मतलब क्या है? इसका मतलब ये है, द पी विल टेल यू द पेज नंबर विच पर्टिकुलर पेज द सीपीयू इज ट्राइंग टू एक्सेस, एंड डी विल टेल यू ओके वर्ड. ओके, पी बता रहा है कौन सा पेज को एक्सेस करना चाह रहा है, और डी बता रहा है वो पेज के अंदर कौन सा वर्ड को एक्सेस करना चाह रहा है. लिसन हियर. ओके, एवरी पेज इज हैविंग हाउ मच साइज? 1 किलोवर्ड्स ऑफ साइज. इसके अंदर 2 पावर 10 वर्ड्स है. उसके अंदर कौन सा वर्ड को एक्सेस करना है वो कौन बताएगा? ओके, डी विल टेल यू दैट. Okay, D will tell you the word number inside the okay page. So now let us say CPU is trying to access page number 5. Example, CPU is trying to access page number 5. Page number 5 को access करना चाह रहा है. Then what will be the first 3 bits here? CPU is trying to access page number 5. Then what will the first 3 bits? Okay, 1 0 1. Is that clear? Now let us say CPU is trying to access page number 3. CPU is trying to access the page number 3. So then what will the first 3 bits here? 0 0 1 1. Okay, CPU is trying to access page number 3, so that will be 0 1 1. Okay, right? So understand here, 0 1 1. Okay, you take that page number. Okay, index onto the page table here. Okay, look at here, you take that page number, index onto the page table here. Index onto the page table, you take that page number, index onto the page table here, and inside the page table entry, listen carefully. Okay, you take that page number, index onto the page table here. Okay, CPU is trying to access page number 3, you take that page number. Page number 3 access करना चाह रहा है, तो first 3 bits क्या होगा? 0 1 1. So you take that page number, index onto the page table. Okay, index onto the page table, and inside the page table entry, you are having what? Frame number. इसका मतलब क्या है? This particular page of LAS, this particular page of LAS is available in this particular frame of PAS. Page table entry contains what? Frame number. देखो page number 3 is available in the frame number 2 1 0. देखो यहाँ पे page number 3 is available in the frame number 2. Okay, 1 0. Okay, binary format में. So page number 3 is available in the frame number 2. Understand here. So you take that page number. Okay, you take that frame number from the page table entry, and then now you try to make the physical address. Okay, look at here. You take that frame number. You take that frame number. And understand here, okay, you make the physical address. Okay, so the answer is no there. You take that page number, frame number, and you make the physical address. So what is that here? 1 0. Okay, now the answer is no important point. You take the page number from the logical address, index onto the frame table, sorry, page table, and inside the page table entry you are getting what? Frame number. So it means page number 3 of LAS is available in the frame number 2 of PAS. Now remember, okay, once you get the frame number, you make the physical address. Once you get the frame number, you make the physical address. Remember, the ultimate goal is to find out the frame number. Ultimate goal is to find out the frame number, because the frame number will tell you the physical existence of the page. Physical existence of the page, where the page is actually available in the main memory. where the page is actually available in the main memory. So now once you get the frame number, you make the physical address, and remember whatever the D you are having in the logical address, D क्या बताता है? Word number. वो पेज के अंदर कौन सा वर्ड को एक्सेस करना चाह रहा है. वॉट एवर द वर्ड नंबर यू आर हैविंग, वॉट एवर द डी यू आर हैविंग इन द लॉजिकल एड्रेस, द सेम डी विल बी कॉपीड फ्रॉम लॉजिकल एड्रेस टू फिजिकल एड्रेस. Okay, why? Because the word number inside the page and word number inside the frame both are same, because page size is same as frame size. So you copy the same D from logical address to physical address. देखो यहाँ से आपको frame number मिल गया. So it means you need to go to frame number 2. PIS में फ्रेम नंबर 2 में जाना है, 102, सॉरी 10 means 2, राइट. सो फ्रेम नंबर 2 में जाना है, तो यू टेक दैट, ओके, यू गो टू द फ्रेम नंबर 2 या, ओके, यू टेक द फ्रेम नंबर 2. फ्रेम नंबर 2 में पेज नंबर 3 है. अब फ्रेम नंबर 3 के, ओके, पेज नंबर 3 के अंदर यहाँ पे फ्रेम नंबर 2 में पेज नंबर 3 है. ये पेज नंबर 3 में कौन सा वर्ड को एक्सेस करना है? इसके अंदर 2 पावर 10 वर्ड्स है, क्योंकि इसका साइज 1 किलो वर्ड्स है, 1 किलो वर्ड्स है, 2 पावर 10 वर्ड्स है. कौन सा वर्ड को एक्सेस करना है इसके अंदर, वो कौन बताएगा? डी बताएगा. ओके, दिस 10 बिट्स विल टेल यू. ओके, नाउ लेट अस से एग्जांपल वर्ड नंबर 5 में जाना है मेरे को. यहाँ पे ये पेज नंबर 3 के अंदर वर्ड नंबर 5 में जाना है. तो व्हाट विल बी दिस 10 बिट्स हियर, व्हाट विल द 10 बिट्स हियर? 0000000, लास्ट में 101. वर्ड नंबर 5 में जाना है, तो ओके, 00, 10 बिट्स का है, 00000, लास्ट में 101 होगा, राइट. सो यू टेक दैट वर्ड नंबर एंड यू गो टू द रेस्पेक्टिव वर्ड, लेट्स से वर्ड नंबर 5, you go to the respective word inside the, okay, frame here, okay, inside the frame, or you say inside the page. Is that clear? So you go to the respective word, okay, you access that particular word, okay. Look at here, you access that word, okay, you go to the respective word here, and inside that word you will have what? क्या होगा? Inside that word you will have the actual instruction of the process. Okay, inside that word you will have the actual instruction of the process. And remember, once you go to that respective word here, inside that you will have the actual instruction of the process. Okay, the CPU will fetch that instruction. And continue the execution. Is that clear? So वो कैसे fetch करेगा, कैसे decode करेगा, execute करेगा, all that part you will study in the computer organization. Okay, instruction execution cycle. Is that clear for everyone? Is that clear? So once you get that, okay, once you go to that particular word, inside that word you will have the instruction. The CPU will fetch that instruction and continue the execution. Is that clear? So I write here properly, right? So this is how. Okay, look at here. Okay, so this is how the paging will be implemented. Is that clear? So now you need to understand here. Okay, look at here. It does know the 13 bits of logical address. Here 13 bits logical address. Look at here. So 13 bits of logical address is getting mapped to, okay, look at here, 12 bits of physical address. 12 bits of physical address. So how this is actually happening? This actually happening with the help of a page table. This actually happening with the help of what? Page table. Is that clear for everyone? Yes or no? Okay, right. Now, right. Next. Now understand. I'll take some example. Okay, कुछ example लेके दिखाता हूँ, थोड़ा आपको clearly समझ में आएगा. अगर अभी भी किसी को doubt है, okay, थोड़ा doubt होता है, small doubt. Listen here. So let's say CPU generating 13 bits logical address. So CPU generating 13 bits logical address. So 13 bits logical address क्या होगा? Let's say example. Let's say CPU generating 13 bits logical address. So 0 1 1 0 0 0 0 0 0. Okay, look at here, 0. Okay, so this is a 1 0 1. Okay, example, just example, some random example I am taking. So CPU generated 13 bits logical address. So this is the 13 bits logical address, it is generated. Okay, so this 13 bits logical address, okay, CPU generated. Okay, बताओ. Okay, 13 bits logical address है, CPU ने इसको generate किया. So ये 13 bits logical address we divide into two parts. Okay, the first 3 bits you take it as a page number, and next 10 bits you take it as what? Okay, page offset. Page offset मतलब क्या है? Word number inside the page. Okay, right. So page number 3. Okay, look at here, 011. You take that page number. Okay, look at here, you take that page number, index onto the page table here. Okay, you take that page number, index onto the page table, and inside the page table entry you are having what? Frame number. Okay, you take that frame number. Okay, what is the frame number? 10. It means this particular page of LEIS is available in this particular frame of PAS. Okay, look at here. So you take that frame number. Okay, you take that frame number and make the physical address. So frame number 10 aa gaya, F and D. Okay, look at here. So this is okay, your physical address. So physical address will be what? 12 bits, and whatever the D you are having here, you copy the same D from logical address to physical address. So what is that D value you are having? 0000, okay, 00101. So you copy the same D from logical address to physical address. Okay, now it means you need to go to this particular address in the PAS. So this will tell you frame number, this will tell you okay frame offset here. So what is the frame number? 10. So you go to the frame number 10, frame number 2 पे जाओगे, frame number 2 पे जाओगे, and inside the frame which particular word you need to access? Word number 5. So you go to respect to word inside the frame here, and inside that word, okay, you will have what? Actual instruction of the processor. So the CPU will fetch that instruction and continue the execution. Is that clear? So this is the example. Okay, take this as example. So copy everything on the board, पूरा अच्छे से copy करो. ओके, नोट्स को टर्न करो. ओके, इसके बाद बहुत सारे इंपॉर्टेंट पॉइंट बताऊंगा, बहुत सारे चीजें डिस्कस करना है. छोटा छोटा डाउट है उसके बारे में मत सोचो. डाउट अगर है अच्छे से लिख के रखो, बाजू में लिख के रखो. अगर डाउट क्लियर नहीं हुआ, ओके, वेट फॉर 2 to 3 days. आफ्टर दैट ऑटोमेटिकली ऑल योर डाउट्स विल बी क्लियर्ड. ओके, मेक ए प्रॉपर नोट. अगर डाउट है तो लिख के रखो, डाउट ऑटोमेटिक क्लियर होगा. राइट. सो ओके, टेक दिस एज एग्जांपल. ओके, एंड कॉपी एवरीथिंग. नोट्स को टर्न करो. ओके, नोट्स तुम्हारा जो भी है उसको टर्न करके पूरा डायग्राम कॉपी करो. देखो यहां से यहां तक पूरा डायग्राम अच्छे से कॉपी करो. ओके, नोट्स को टर्न करके पूरा डायग्राम अच्छे से कॉपी करो. मेक ए प्रॉपर डायग्राम. नोट्स को टर्न करो एंड टेक दिस एग्जांपल आल्सो. आई विल वेट 5 seconds इन द लाइव. ओके, ओनली 5 seconds और 10 seconds. आप पास कर लो, वीडियो पास करो. वीडियो पास करके मैं साइड हो जा रहा हूं. कंप्लीट. आई थिंक नाउ यू कैन पास. पूरा डायग्राम अच्छे से कॉपी करो. Okay, right. So I am assuming all of you copied. If you are still not copied, you can pause my video. Right. Okay. Right. So understand here. Next, let's discuss okay, important points. Okay, understand here. So small point I want to convey. Okay, small point. Okay, when you are writing the frame number here, listen carefully. When you are writing the frame numbers here, frame number okay 00 लिखा है. 00 लिखा है यहाँ पे. 00 मतलब 0 ओनली. सो 00 लिखे तो भी 0 ही होगा. ओके, फ्रेम नंबर के लिए 2 बिट्स 00 लिखा है. सो 00 ऑल्सो 0 ओनली. 00 का अपन सिंगल 0 भी लिख सकते हैं. ओके, 000 भी लिख सकते हैं, 00 भी लिख सकते हैं. ओके, 4 zeros भी लिख सकते हैं. आप कितने भी 0 लिखो 0 ही होगा ना. राइट. फिर मैं 2 0 00 ही क्यों लिखा है? 00 ही क्यों लिखा है? Okay, I want to write the frame number 0 here. Okay, I have written 2 zeros here. Okay, even if you write 10 000 40, that is all 0 only, right? But why I have written only 2 zeros? Because okay, frame number requires how many bits here? Frame number requires how many bits? 2 bits. So if the frame number requires 2 binary bits, wherever you write the frame number, you write only 2 bits okay, of frame number. Now let us say, listen to me, okay, small point. Let us say you are having 128 frames. Example 128 frames. If you are having 128 frames, frame number requires how many bits? Frame number requires how many bits? 7 bits. Very good. So frame number requires 7 bits means what? All zeros to, okay, look at it, all zeros to what? All ones. Okay, no need to copy, all zeros to all ones. It means what? Wherever you write the frame number, you write how many bits? 7 bits only. इफ यू आर हैविंग 128 फ्रेम्स, 128 फ्रेम्स के लिए कितना बिट चाहिए? 7 बिट चाहिए, all zeros to all ones, okay, like this, okay, 7 zeros to 7 ones, okay. So wherever you write the frame number, you write only 7 bits, is that clear? So that is the reason ना, और यहाँ पे फ्रेम नंबर 0 के लिए क्या लिखा है? 2 बाइनरी बिट लिखा है, ओके, 00 लिखा है, क्योंकि फ्रेम नंबर के लिए यहाँ पे कितना बिट चाहिए अपने को? 2 बाइनरी बिट चाहिए. So that point you should remember. No need to copy मत करो, इसको याद रहेगा ना. Okay, fine. So next, okay, next continuation, okay, keep the heading important points. Keep the heading important points. Note down. Okay, so let's see how many points will come. Right, keep the heading important points. Note down first point. Keep the heading important points. Point number 1. Point number 1. Whenever the process is created, whenever the process is created, paging will be applied. Paging will be applied on the process. Paging will be applied on the process. Paging will be applied on the process, and page table will be created. Paging will be applied on the process, and page table will be created, and base address of the page table. Base address of the page table, base address of the page table will be stored in the, base address of the page table will be stored in the PCB, process control block. Base address of the page table will be stored in the PCB, process control block. Is that clear? Right, मैं रिपीट कर रहा हूँ. ओके, एंटायर पॉइंट. फर्स्ट पॉइंट फिर से बता रहा हूँ. व्हेनेवर द पेजिंग इज अप्लाइड, ओके, व्हेनेवर द पेजिंग इज अप्लाइड, व्हेनेवर द प्रोसेस इज क्रिएटेड, व्हेनेवर द प्रोसेस इज क्रिएटेड, paging will be applied on the process, paging will be applied on the process, and page table will be created, full stop. The base address of the page table will be stored in the PCB. Okay, that is the first point. And second point लिखो. Second point, paging is with respect to every process. Paging is with respect to every process. Paging is with respect to every process, and every process will have its own page table. Every process will have its own page table. Okay, full stop. Next, okay, third point, page tables of the processes, page tables of the processes will be stored in the, main memory. Page tables of the process will be stored in the main memory. Okay, full stop. Next, point number 4. There is no external fragmentation. There is no external fragmentation in the paging. There is no external fragmentation in the paging. There is no external fragmentation in the paging. Next, point number 5. Point number 5. The internal fragmentation exists. Internal fragmentation exists in the last page. यहाँ पे लिख रहा हूँ. Internal fragmentation exists in the last page. LAST, last. okay, the internal fragmentation exists in the last page, last page, and internal fragmentation exists in the last page, and internal fragmentation in the paging, and internal fragmentation in the paging is considered as a P by 2. यहाँ पे लिख रहा हूँ internal fragment in the paging is considered as a P by 2, where P is the page size, is considered as a P by 2, where P is the page size. Okay, right. So I am repeating, okay, the internal fragmentation exists, okay, in the last page, and internal fragment in the paging is considered as a P by 2, where P is the page size. Okay, full stop. Next, point number 6. Maintaining the page table. Is considered as a overhead for the system. Maintaining the page table is considered as a overhead for the system. Okay, understand here. Okay, so understand carefully, understand all the points one by one. Okay, the answers not just say, so this is all important. Okay, so the answers not just say, right. So listen carefully. So first point क्या लिखे, first point पढ़ो अच्छे से क्या लिखे, first point. Okay, whenever the process is created. Okay, now tell me, whenever the process is created, creating the process means what? Everything is a process only. अगर आप कोई application चला रहे हैं, that's a process. कोई गाना चला रहे हैं, you are playing some song, that is also a process. You are playing some movie, that is a process. Okay, you are playing some game, that is also okay process. So whenever okay process is created, paging will be applied on the process. Paging will be applied on the process. It means what? We are going to divide okay that into pages. Okay, right. Remember page size will be always constant in the system. Okay, page size is already defined in the operating system. Okay, right. Page size is a predefined. Okay, page size is a predefined. When you design the operating system, at that time only you decide for the page size. Okay, remember Windows practically follows. Note down, keep it as note. Continuation में लिखो, Windows practically follows page size of 4 KB. लिखो अच्छे से, Windows practically follows page size of 4 KB. Okay, right. So याद रखना है इसको, right. Okay, practically जो अपन Windows follow कर रहे हैं उसमें practically page size कितना है, 4 KB है. Okay, so I am repeating first point. Okay, first point फिर से बता रहा हूँ. Okay, whenever the process is created, paging will be applied on the process. Okay, we are going to divide the process into pages. Is that clear? So okay, obviously page size constant रहेगा. Okay, predefined रहेगा. So okay, 4 KB है, whatever it is. Okay, you divide that into pages. Right, and remember next page table will be created. So page table process के लिए बन जाएगा. Process के लिए page table बन जाएगा. And important next point and base address of the page table will be stored in the PCB. Okay, so ये page table main memory में कहाँ पे, ये page table memory में कहाँ पे, उसका base address मतलब starting address, base address है. Okay, will be stored in the PCB, process control block का PCB में आएगा. इसका मतलब एक इंपॉर्टेंट पॉइंट समझ में आना चाहिए. अभी पेजिंग इंप्लीमेंट करने से एक प्रोसेस का नया एट्रीब्यूट आ गया. नया एट्रीब्यूट कहां पे आ गया, पीसीबी में आ गया. व्हाट इज दैट न्यू एट्रीब्यूट? द बेस एड्रेस ऑफ द पेज टेबल विल बी स्टोर्ड इन द पीसीबी. इज दैट क्लियर फॉर एवरीवन? यस और नो? राइट, एक नया एट्रीब्यूट आ गया. इसका मतलब प्रोसेस का कॉन्टेक्स्ट बढ़ गया. Process का context बढ़ गया. Is that clear? So you need to remember that. Okay, the context of the process is increasing because you are having some additional attribute in the PCB. What is that additional attribute? The base address of the page table will be stored in the PCB. So that is the first point. Okay, and next now coming to the second point. Okay, second point क्या लिखे? paging is with respect to every process. Paging is with respect to every process, and every process will have its own page table. Yes. So whatever the paging we are studying here, this is with respect to every process. Every process will have its own page table. हर process का अपना अपना page table होगा. And the next point क्या लिखे? Next point, page tables of the processes will be stored in the main memory. Whatever the page table you are having, so the page table will be stored in the main memory only. पेज टेबल कहाँ पे स्टोर होता है? मेन मेमोरी में स्टोर होता है. राइट. नेक्स्ट पॉइंट. ओके, पॉइंट नंबर 4 क्या लिखे थे? देयर इज नो एक्सटर्नल फ्रैगमेंटेशन इन द पेजिंग. ओके, सो दिस इज इंपॉर्टेंट. बताओ आप लोग. सी फर्स्ट ऑफ ऑल, व्हाई वी केम फॉर पेजिंग पे क्यों आए थे? टू अवॉइड द एक्सटर्नल फ्रैगमेंटेशन ओनली. सो ऑब्वियसली देयर इज नो एक्सटर्नल फ्रैगमेंटेशन इन द पेजिंग. ये बोल रहा है देयर इज नो एक्सटर्नल फ्रैगमेंटेशन इन द पेजिंग. नाउ टेल मी व्हाई देयर इज नो एक्सटर्नल फ्रैगमेंटेशन. मैं आपसे पूछ रहा हूं. ओके, यहाँ पे कोई एक्सटर्नल फ्रैगमेंटेशन नहीं है. ओके, आई एम आस्किंग व्हाई देयर इज नो एक्सटर्नल फ्रैगमेंटेशन हियर. व्हाट इज आंसर? ओके, राइट, somebody is thinking correct. So understand here, so why there is no external fragmentation? Because the page size is same as what? Frame size. Page size is same as frame size. Okay, it means, listen here, see, first of all, what is external fragmentation? We had that in the yesterday class. Okay, in the previous session. Okay, external fragmentation means यहाँ पे थोड़ा बच गया, यहाँ पे थोड़ा बच गया, यहाँ पे थोड़ा बच गया, यहाँ पे थोड़ा बच गया. अगर कोई बड़ा प्रोसेस आया उसको अपन यूज नहीं कर पा रहे. So that is the external fragmentation. Yes or no? Right? Now remember, वो situation यहाँ पे आएगा ही नहीं है. Okay, you will not have that kind of a problem here. Why? Because whatever the page you are having, that will automatically fit inside the frame here. ऐसा नहीं कि यहाँ पे थोड़ा बचा है, यहाँ पे थोड़ा बचा है, यहाँ पे थोड़ा बचा है, ऐसा सिचुएशन नहीं आएगा. क्योंकि ये छोटा साइज है, ये बड़ा साइज है, इसमें फिट नहीं हो रहा है. ओके, ये अलग साइज फिट नहीं हो रहा है. ऐसा सिचुएशन तो आएगा ही नहीं. Is that clear? Right? So whatever the page you are having, that will automatically fit inside the frame. Is that clear? So there is no external fragmentation. Is that clear? Right. Next. Now coming to the last point. Okay. Next. Fifth point क्या लिखे? Fifth point में क्या लिखे? पढ़ो अच्छे से. The internal fragmentation exists in the last page. Okay, understand here. Internal fragmentation तो last page में होगा ना, right? कैसे? For example, listen here. Page size is a predefined in the operating system and page size is a constant. Page size तो constant है, but process size will change, right? Process size will vary. Okay, you may write a big application, small application, बड़ा process है, छोटा process है, कुछ भी हो सकता है, right? So process size तो अलग अलग होगा, page size तो same है. Sorry. Now, when you divide the process into pages, last page also cannot be full, right? Last page will complete full होना बोल के गारंटी नहीं है ना. Yes or no? समझ में आ रहा है? नहीं आ रहा है. ओके, समझ में नहीं आ रहा है. सुनो अच्छे से. ओके, सी, रिमेंबर, ओके, internal fragmentation exists in the last page. So look at here, page size is a constant but process size will differ. Okay, so when you divide the process into pages, एक बड़ा process है, उसको ऐसा divide करते आ रहे हैं पेज लेके, divide करता है तो last page भी पक्का full होना बोल के गारंटी नहीं है ना. ओके, नहीं आ रहा है समझ में, राइट? ओके, इधर सुनो. लेट्स से एग्जांपल. ओके, प्रोसेस साइज. ओके, सो नाउ टेल मी प्रोसेस साइज एज एग्जांपल 15 KB. ओके, एग्जांपल. नेक्स्ट, पेज साइज. ओके, लेट्स से इफ आई टेक 4 KB. बताओ नंबर ऑफ पेजेस कितना आएगा अगर इसको मैं डिवाइड करता हूं. नंबर ऑफ पेजेस, बताओ नंबर ऑफ पेजेस कितना आएगा? 15 KB डिवाइडेड बाय 4 KB. सो डिवाइड किया KB. सो ये क्या है? 3 पॉइंट कितना रहा है? 15 डिवाइडेड बाय, ओके, हाउ मच इज दैट? Okay, so something, okay, you get some value. Okay, so understand here, 3 point something you are having. Okay, example I say, okay, 3.7, whatever it is, 3.7, 3.8, whatever you get. So understand here, what is the problem here now? Okay, 15 KB divided by 4 KB करे तो ये 3.7 पेजेस आया. नंबर ऑफ पेजेस 3.7 पेजेस आया. सी, 3.7 पेजेस हो सकता है क्या? 3.7 पेजेस तो नहीं होगा, राइट? ऑब्वियसली कितना पेजेस लेना पड़ेगा? 4 पेजेस ही लेना पड़ेगा. इज दैट क्लियर? सो ऑब्वियसली यू हैव टू टेक द 4 पेजेस ओनली, राइट? सो इसका मतलब क्या है? 4 पेज ले रहा है, 3 पेजेस तो पक्का फुल है. ओके, फर्स्ट 3 पेजेस तो पक्का फुल होगा. लास्ट पेज में क्या है बताओ? 70% फुल रहेगा और नेक्स्ट 30% विल बी व्हाट? 30% विल बी, ओके, एम्प्टी, खाली रहेगा. इंटरनल फ्रैगमेंटेशन. एंड नेक्स्ट ध्यान से सुनो, अगर ऐसे ही मैं डिवाइड किया एग्जाम्पल, अगर ऐसे ही मैं डिवाइड करे तो एग्जाम्पल डिवाइड करे तो मेरे को 3.1 आया, एग्जाम्पल डिवाइड करें तो 3.1 पेजेस आया, 3.1 पेजेस आया तो भी कितना पेजेस लेना पड़ेगा, 4 पेजेस ही लेना पड़ेगा। ओके, इसका मतलब 3 पेजेस तो पक्का फुल है और लास्ट पेज में 10% फुल है, 90% खाली है। अगर ऐसे ही डिवाइड किया मेरे को 3.9 आया, 3.9 आया तो भी कितना पेजेस लेना पड़ेगा, ओके 4 पेजेस ही लेना पड़ेगा, 4 पेजेस ही लेना पड़ेगा। इसका मतलब 3 पेजेस पक्का फुल रहेगा और लास्ट पेज 4th पेज में क्या होगा, 90% फुल रहेगा, 10% खाली रहेगा, मतलब इंटरनल फ्रैगमेंटेशन होगा। तो इसका मतलब कभी कभी लेस देन ऑफ इंटरनल फ्रैगमेंटेशन, कभी कभी लेस देन ऑफ इंटरनल फ्रैगमेंटेशन, कभी कभी ओके लुक एट हियर, कभी कभी आधा से ज्यादा इंटरनल फ्रैगमेंटेशन हो रहा है, कभी कभी आधा से कम इंटरनल फ्रैगमेंटेशन हो रहा है। एग्जांपल लुक एट हियर, देखो यहाँ पे 3.9 है, कितना इंटरनल फ्रैगमेंटेशन है, लास्ट में 10% है। यहाँ पे 3.1 पेजेस है, कितना इंटरनल फ्रैगमेंटेशन है, ओके लास्ट पेज में 90% इंटरनल फ्रैगमेंटेशन है। सो समटाइम्स 90% इंटरनल फ्रैगमेंटेशन, कम समटाइम्स ओके 10% इंटरनल फ्रैगमेंटेशन, मतलब एवरेज, कभी कभी हाफ से ज्यादा, कभी कभी हाफ से कम। सो एवरेज मान के चल रहा है, एवरेज मान के चल रहा है। द इंटरनल फ्रैगमेंटेशन इन द पेजिंग इज कंसिडर्ड एज व्हाट, क्या लिखे नोट्स में, इंटरनल फ्रैगमेंटेशन पेजिंग इज कंसिडर्ड एज हाउ मच, p/2, ओके वेयर p इज द पेज साइज। इसका मतलब एवरेज अपन क्या ले रहा है, हाफ पेज, ओके। सो p/2 मतलब क्या है, आधा पेज ले रहा है, क्योंकि कभी कभी हाफ से ज्यादा होगा, कभी कभी हाफ से कम होगा। सो इसलिए इंटरनल फ्रैगमेंटेशन कंसिडर्ड एज व्हाट, हाफ पेज, ओके राइट। सो p/2 दैट इज हाफ पेज, ओके। नेक्स्ट पॉइंट लिखो, नेक्स्ट पॉइंट क्या लिखे, लास्ट पॉइंट maintaining the page table is considered as the overhead for the system, okay। So whatever the page table okay we are maintaining, whatever the page table we are maintaining, that is the overhead for the system। overhead मतलब क्या है, okay overhead लिखिए ना सब लोग, overhead मतलब क्या है, burden it means what, unnecessary wastage of the memory, unnecessary wastage of the memory। So page table is considered as the overhead for the system, unnecessary wastage of the memory। Is that clear for everyone, okay। So that you should remember, the simple point only, okay। So page table maintain करना overhead माना जाएगा, okay। overhead मतलब क्या है, burden, unnecessary wastage of the memory, okay। So that is the meaning of that, okay fine। So that is the okay all the points and all that। Next note down continuation, okay note down the statement, keep it as a note, keep it as note। एक statement लिखो, एक स्टेटमेंट लिखो, पेज टेबल नो डाउट, पेज टेबल एंट्री note down this point, page table entry definitely contains, page table entry definitely contains frame number, page table entry definitely contains a frame number, but sometimes along with the frame number, sometimes along with the frame number it may also contain additional bits, it may also contain additional bits, okay right। So what is the meaning of this इसका मतलब समझो अच्छे से, बताओ मैं किसका बात कर रहा हूँ, it may also contain additional bits, what is that, you will understand that now। क्या लिखे फर्स्ट, पेज टेबल एंट्री, बताओ डायग्राम में बताओ, पेज टेबल एंट्री डेफिनेटली कंटेन्स फ्रेम नंबर बोला, पेज टेबल एंट्री मतलब कहाँ पे, डायग्राम में कहाँ है बताओ, डायग्राम में पेज टेबल एंट्री ये वाला, सो दिस इज पेज टेबल एंट्री करेक्ट। सो पेज टेबल एंट्री इसका बारे में बोल रहा हूँ, सो पेज टेबल एंट्री definitely contains what, frame number बोला, so this is a page table entry, page table entry definitely contains what, frame number, but sometimes along with the frame number it may also contain additional bits, sometimes along with the frame number it may also contain additional bits, okay। what is the additional bits, okay look at here, what is that additional bits, copy करो अच्छे से, copy this, so let's say this is a page table entry, okay, page table entry पेज टेबल एंट्री डेफिनेटली कंटेन्स व्हाट फ्रेम नंबर okay copy karo achhe se frame number okay along with the frame number sometimes it will also contain additional bits what is that additional bits okay next valid invalid bit or dirty bit okay sorry valid invalid bit or present bit okay dirty bit or modified bit d or m मैं लिखता हूँ पूरा और next reference bit okay next page protection bits okay so लिखो अच्छे से बताओ first one is what first one okay frame number बताओ frame number एक बार बताओ पहले stop copying now tell me frame number is also called as अभी लिखवाया frame number also called as गजनी बन रहा है गजनी इज ऑल्सो कॉल्ड एज ट्रांसलेशन बिट्स लिखे थे ना गजनी बन रहा है गजनी मतलब शॉर्ट टर्म मेमोरी लॉस हो रहा है सबको राइट सो फ्रेम नंबर इज ऑल्सो कॉल्ड एज ट्रांसलेशन बिट्स ओके नेक्स्ट व्हाट इज दिस हियर VRI सो इसका मतलब वैलिड इनवैलिड बिट वैलिड इनवैलिड बिट और इट इज ऑल्सो कॉल्ड एज अ प्रेजेंट बिट okay so d or m मतलब dirty bit और modified bit बताता हूँ इसके बारे में बताता हूँ पहले कॉपी करो dirty bit और modified bit so ये और मतलब क्या है और मतलब reference bit और मतलब reference bit ओके PP मतलब क्या है बताओ पेज प्रोटेक्शन बिट्स और sometimes it is also called as a permission bits copy this carefully पूरा अच्छे से कॉपी करो the board is visible properly I think you can zoom okay so please copy carefully right so let's understand one by one okay एक एक समझते अच्छे से right okay कॉपी नहीं करे तो पास करके कॉपी करो right so you know what is the meaning of frame number already आपको पता है so no need to worry about that so no need to discuss okay next what you need to understand here valid invalid bit or present bit no doubt keep the heading valid invalid bit or present bit continuation में लिखो keep the heading valid invalid bit or present bit no doubt this bit is used to identify whether the page is available or not available in the main memory. To identify whether the page is available or not available in the main memory. Okay, understand here. So copy karo. Okay, look at here. So that is used to identify whether the page is available or not available in the main memory. So valid invalid bit or present bit. Look at here. It will take two things either 0 or 1. Okay, only one bit hoga. Valid invalid bit or present bit. It takes only one bit 0 or 1. 0 means okay, that is not present. Okay, in the main memory. Not present in the main memory. So 1 means okay, it is present मतलब available okay in the main memory. Copy करो इसको अच्छे से. Valid invalid bit or present bit. It takes only one bit 0 or 1. 0 है तो not present in the main memory. 1 है तो present in the main memory. Copy this. Okay. Next, okay, that is about okay, valid invalid bit. Is that clear? That is used to identify whether page is available or not available in the main memory. अगर वो 0 है तो not available, 1 है तो available. Okay, that's the meaning of this. Okay, no doubt. Next is dirty bit or modified bit. So keep the heading dirty bit or modified bit. Continuation में लिखो dirty bit or modified bit. No doubt, this bit is used. This bit is used to identify this bit is used to identify whether the page is modified, to identify whether the page is modified or not modified, to identify whether the page is modified or not modified by the processor, to identify whether the page is modified or not modified by the processor while accessing the page, as part of the execution, while accessing the page as part of the execution. Okay, full stop. Now understand here. So dirty bit or modified bit. Listen here. What is the purpose of this? This bit is used to identify whether page is modified or not modified by the processor. Okay. Now it means what? Sometimes when you are accessing the page, when the CPU is accessing this page, okay, sometimes what happens, maybe okay, it is some writing some data into the instruction, it is modifying any instruction. While execution, obviously you are taking some input and okay, you are updating some any variable or something like that. Okay, anything will happen. So if it is modified this instruction, if it is modifying any instruction in this, so then it will simply set modified bit to what? 1. Okay, if the modified bit is 1, it means modified. Okay, page is modified. Modified bit, okay, dirty bit, it is 0, it means what? Not modified. Okay, so no down. So this will also take only 1 bit. Okay, it will also take only 1 bit. D, okay, modified dirty bit or modified bit, it takes only 1 bit. 0 or 1, 0 है इसका मतलब that page is not modified, 1 है तो that is page is modified. Copy करो इसको भी. So when you are accessing the page, sometimes it may modify. Is that clear? Why? Maybe okay, while accessing it is changing any instruction in that. Okay, if it is modified, it will simply set the modified bit to 1. Is that clear? So that is the meaning of dirty bit or modified bit. Okay, no doubt. The next is a reference bit. Reference bit. No doubt. This bit is used, no doubt, reference bit. This bit is used to identify how many times the page is referred, to identify how many times the page is referred while performing the execution. How many times the page is referred while performing the execution. Okay, full stop. Now it means what? Sometimes the same page may be referred okay 2 times, 3 times, something like that. Just like any function call is there in your program, some function call is there, you are calling the same function again and again. It means what? The same function, okay, same page will be referred multiple times. So how many times that page is referred while performing execution? So that is maintained in the reference bits. Now how many bits will be there for reference bit? There is no fixed bits, okay, for the reference fixed number of bits for the reference bit. Okay, it may be having okay 1 bit or 2 bits or 3 bits or 4 bits. That depends on the availability when you are designing the operating system. इसके लिए कोई fixed number of bits नहीं है. Is that clear? So that is about a reference bit. Okay. So next is no doubt. Next page protection bits or permission bits. No doubt. Last one, page protection bits or permission bits. Note down, these bits are used, these bits are used to identify, these bits are used for the protection and security. These bits are used for the protection and security, for the protection and security from unauthorized access. These bits are used to identify for the protection and security from unauthorized access. Unauthorized access. Okay, full stop. Okay, right. Understand here. So what is the meaning of this? Okay, page protection bits or is also called permission bits. So these bits are used to, okay, for the protection and security from unauthorized access. Unauthorized access, it means what? Some illegal user trying to access your page. Illegal user is trying to access your page, so that is not allowed. Is that clear? So that is the, okay, main purpose is what? Okay, for the protection and security. It means internally the operating system is following any kind of algorithm for the protection purpose. Okay, protection and security purpose also you maintain so many algorithms. Okay, you study all that in the, okay, maybe advanced operating system if you study, okay, then you can understand all that. So not required. Okay, in case, okay, if any algorithm is used for the protection of the processes internally, that related bits will be maintained in the permission bits or you say page protection bits. Is that clear? So इसके लिए कितना bits हो सकता है? How many bits will be there? That is also not fixed. Okay, it may be 3 bits or 4 bits or whatever. Is that clear? So that is the availability, depending on the availability when you are designing the operating system. Okay, right. So that is about all the points and important points. That is okay, the concept of paging. Is that clear? So the next, okay, my job is done. I think almost around 2 hours. Okay, the concept is of 2 hours. So I explained all the points, and the next is your job. Okay, next is your job. So I'll slowly increase the complexity, low level to high level. You are going to solve around 7-8 questions or maybe 9 questions. All the questions you need to solve only. You need to solve only. Okay, so revise the notes properly. अच्छे से revise करो notes. In the next we are going to solve the questions. Around 8 to 9 questions we will solve, and some related थोड़ा concept, थोड़ा okay, नया point भी आएगा. Is that clear? We'll discuss all that. Okay, so thank you so much. Hope you enjoyed the, okay, paging concept. Please revise the notes. The next target is to solve the problems. If you are not solving the problems, there is no meaning of learning the concept. Okay, so all the questions you can solve if you follow the concept carefully, right? So thank you.